Hi there, welcome to the breadboard. Today we have another package from Far Off Lands. This is from RS Components in Europe, and they sent me this to review. It is a temperature sensor that works off of between 12 and 24 volts, has wide temperature ranges, has a built-in display, and many other features that we will go and have a look at right now. So this is new to RS Pro's lineup, and they sent me this so that I can have a look at it, have a play with it, and use it for some of my projects going forward. But today it's a little quick review of the product, so without further ado, let's get into the box and have a look. So here's the packaging. As I said, RS Pro, part number 1618103. So let's have a look. So what we have is the temperature sensor. It's this tiny little thing here. It is 30 by 30 millimeters and comes with an integrated cable, 1 meter long. The ferrules I put on the end myself, along with a little power adapter, so we can have a quick look at this. There we go. So this is the sensor. You see here we've got the So here's the sensor. As you can see, we have a small display. We have what looks like a tick button and a couple of up and down arrow buttons. And we have an integrated cable coming out of this to a connector on the end, which has a ground lead, so shielding. We have plus and minus supply, which can be 12 to 24 volts. And we also have an output for an alarm, which is the yellow wire, and we have a green for output plus. This actually has a plus voltage output that can indicate the reading on the display. So let's grab a convenient 12 volt supply and we'll power this thing up. So it is a little bit springy on the cable. It's not ultra flexible. Here's the display, and we'll just power it up and see what we get. I'm plugging the power in now. I'm using a 24 volt supply. There we go. Sorry about the flicker on the camera. It's just an artifact of the camera. The display itself is actually not flickering at all. And that's it powered up. So you can see, instantly giving a temperature reading. It's using this single sensor on the back. It's not like a FLIR with an array. It's a single sensor and does an averaging of what the sensor can see. And we'll look at the documentation in a moment online, but this is basically it. And now I say that, but the display itself can also show a number of different things using the up and down. Like for instance there, it is showing us a number of different statistics, average, min, I'm just tipping it so I can see what it says. So raw, filtered, average, max, min, and SEN, all on the display there, so it's keeping track of those. Now you can't bring these up via an interface or anything like that, so you just look at them on the display, but you do have the ability to have an output via one of these wires that you can connect to a programmable logic controller or remote display or something like that. Now the other nice thing about this is it is not a contact display. It is, as long as the sensor can see the heated surface. So if I zoom out a little bit for a second, now that we've seen this close up, and I put it, let me just get back to the normal display. If I put my hand under here, I'm not touching my hand, but you'll see that it's gone up to measure the temperature of my hand, 33.3 at the moment. And if I take it away, it's still going to measure a higher temperature because my hand was on the table, so it's actually slowly going down there now as the table cools off. 28, 24, 28.4. Going, if I move it to a different area, see it's 25. So it is quite sensitive to infrared. It has mountings for a machine mounting, or you can get a air collar for this that would prevent any contamination. So if you had it in a dusty or hazardous kind of environment, depending on where you put this in an industrial environment, you can actually have a positive airflow going over the lens so that it doesn't get contaminated. And 2 screw hole mountings are provided there, and they also provide the right threaded screws for mounting it. Now what I probably will do is 3D print something so that I can use it for maybe measuring the temperature of my heat beds on my 3D printers, various other things. It's obviously for industrial use, being powered nominally between 12 and 24 volts, and the 0 to 5 volt or 0 to 10 volt, it's programmable inside here using the setup buttons to output different ranges. And so yeah, I will demonstrate in a minute hooking it up. Anyway, let's go and look at the specifications of the device and figure out how we change its programming. Okay, so here we are on the RS Components website. We're on the RS UK one, just as it happens, and this is the temperature sensor right here. Comes with a 1 meter cable, and as you can see, it will measure between 0 degrees C and up to 1000 degrees C. So my thermal imager that I have from FLIR will only go up to about 150 degrees centigrade, the type that it is. And so this one, having a much bigger range, is better for looking at engines, furnaces, and things like that may go way above 150 degrees centigrade. It is an angled averaging measurement of what the sensor is looking at. So you can see here price as of 24th of May 2018 is £150. That's excluding VAT. Obviously your prices will vary depending on what region you are in. RS provide both a instruction manual and a data sheet for this. We'll have a look at those in just a moment. Product details: no contact infrared temperature sensor. Obviously the spot that is measuring will depend on the distance between the sensor and the surface. The sensor can be used at long distances and will measure a large spot. Accuracy of the sensor is not affected by the measurement distance, which means that even if you're measuring something, say 10 feet away, it's still going to be as accurate as something that you're maybe measuring 20 centimeters away. It's just that the spot that it's going to be looking at is going to be much larger. It's industrial temperature sensor, and it has simultaneous voltage and alarm outputs. I've already mentioned the fact that you can have a 0 to 5 volt DC output or a 0 to 10 volt output, which is linear to the temperature range. It's got an open collector alarm output, which means you could drive a relay or the input to a PLC or something like that with the relay if you wanted to. And I've already mentioned that. IP65 rated, which is great. There's a couple of devices, a mounting bracket. Let's have a quick look at that. So here's an industrial style mounting bracket that allows you to adjust the angle and direction of view for the device. So this is they call it an RS Pro air purge collar. What this does is it basically screws to the sensor side of the temperature sensor, and you would feed it a low pressure flow of air, and it would put a flow of air through onto the surface of the sensor and then out of the hole. So data sheets, let's have a look here. We've got the instruction manual, RS Pro infrared temperature sensor. We've already seen it on the bench measuring raw temperatures, and it's got, if you notice, there's this little padlock here which tells you that the settings have been locked in the device. So there we go. Here's our first indicator of what it's doing. It's got a 15-degree divergent optics, which means that it's, from the lens looking out, it's a 15-degree angle. So the further away you go, that bigger that spot is going to become. So accuracy is 1.5% of the reading, or 1.5 degrees C, whichever is greater. So in the lower temperature ranges, its accuracy is going to be about 1.5 degrees C. Once you get up to about 100 degrees centigrade that you're measuring, then the 1.5% would take over. And so, if you're up at, say, 200 degrees centigrade, then it's going to be about 3 degrees potentially out. It may not be, but it's allowed that within its tolerance. Response time 250 milliseconds, so it's basically doing 4 measurements per second. Emissivity is also adjustable via those buttons that we saw on the front of the display, and you can adjust it anywhere from 0.2 right up to 1.0. You can adjust the temperature span for the output, not for the actual sensor itself or the display, but for the output, the voltage output. You can adjust it from 100 degrees C to 1000 degrees C. So for instance, if you had a 0 to 5 volt output set, you could set this to say 500 volts, and your voltage output would directly relate to the temperature that you're measuring. You could also have a 0 to 10 volt output and set your temperature range for the output to also represent, say, 0 to 100 degrees C, and then you would also have a direct correlation with the temperature, which means setting up a remote display or something would be much, much easier. The open collector output can drive up to a 50 milliamp load, somewhere between 6 and 24 volts DC. And you can change the signal processing. Remember, we looked at the display. You can see the average, min, max, etc., etc. You can change the period of the processing from 4 times a second right up to once every 60 seconds. Peak and valley holding period as well, for between a half a second, and so you can go up to about a 20-minute period for peak and valley holding for temperatures. Here's a nice diagram that shows what I was talking about as far as the spot measurement distance getting bigger as you have your target further and further away. So for instance, if you're at 20 inches away from the device, your spot diameter is going to be 1.7 inches is what you're going to be measuring. If you're 40 inches away, then your spot diameter is going to be about 3 inches. Again, if you go to millimeters, if you're a meter away, 76 millimeter spot diameter, etc., etc. So that's actually quite a narrow angle. I don't know whether it would be good enough to measure. Well, it only goes down to 0.4 inches. So, if you're trying to measure, say, a soldering iron temperature or something like that, it would be smaller than the 0.4. So you would get averaging of other things interfering with your readings. And I think this diagram here accurately reflects what I'm talking about. So at this first target, where the target itself is bigger than the spot size, then the average is going to encompass the entire well, not the entire target, but within the target, which means it's going to give you an accurate temperature reading. On this second target, the target itself is smaller than the spot size. And what's going to happen here is it's going to include some of the temperature readings in the averaging, even from the raw data is averaged of what the sensor is seeing, will include background. So if you have a small spot here, and maybe this is sitting at 150 degrees centigrade, maybe it's the bed of a 3D printer, just for argument's sake, and you're far enough away that you're also including the bench and other things around that, then the temperature is going to read lower because you've got this 20-25 degrees centigrade background that's around the periphery of the sensed object. So you need to be aware of that when you're using this and setting it up. 4 wires coming out aside from the ground, this shield. We have the red power plus, which is the nominal 24 volts, the blue power minus. We have the green wire, which is labeled OP plus, which is our output that will go to some kind of meter, and that could be a PLC, it could just be a panel meter that's remotely mounted, whatever you need for your solution. And then you've got the yellow wire, which is a open collector, which can drive up to 50 milliamps. So here they've got a protection diode and perhaps a low-powered relay connection. It's a coil here that would energize to alert some kind of condition remotely to the alarm threshold being reached. Yeah, operation, really simple. Turn on the power supply, turn on the measurement instrument, read the temperature. You're done. Right? Pretty simple, very easy to use, very, very easy to read as well. The temperature of the housing does have some kind of effect here, and it's actually saying here as a warning that if you have a significant change in ambient temperature, hot to cold or cold to hot, give it 20 minutes for the sensor body to stabilize before relying on the readings that it's giving. So all the rest are fairly standard warnings. Sensor that has no usable serviceable parts. It is not designed to be open. So the only other thing to really have a look at is how do you program this. So press the tick button to enter, go away, come on, the settings menu. By default the sensor is locked and the settings can be viewed but not adjusted. To edit the settings, scroll to the enter pin, press down once. The pin is 8103 by default. So it's recommending that you potentially paint the area to reduce reflections and increase its emissivity, which is a common practice. You could even put a piece of black matte tape or something over a part of it, as long as it encompasses the sensed area, so that you can get a better accurate reading of the temperature of the device that you're looking at, not things that are being reflected from around it. I'm not going to read through every single thing in here because, well, you can do that yourself. Please that. Now, there was one other document here, which is this one, which is just the simple data sheet. Again, a repeat of all the specifications, input voltages, conformity. So that's all of the information that's provided with this, and really that's all you need. So the next thing to do is get back to the unit and see if we can, I'll plug in a digital multimeter to the output, and we'll just verify that, and we'll change its settings from, say, 0 to 5 volt, 1 to 5 volt, and a 0 to 10 volts, and we'll just see how easy it is to program it. Okay, so we're back on the bench. I've hooked up my appropriately FLIR DM284 multimeter to monitor the DC voltage output, and we've got a 22.9 degrees output currently being displayed on the temperature sensor. So because I think the default is 0 to 5 volt out, that should equate to about 114 millivolts. So for whatever reason we're a little bit low on the millivolts. Let's change the range and see how hard that is to do. So it says to push this button here, and okay, so we're in programming. So it currently says emissivity, and it's also got the lock symbol up, so we need to go down, enter pin. Must be suffering from a little bit of numeral dyslexia. It's 8103, which happens to be the last 4 digits of the RS stock part number. Clever RS folks there, using the default pin as the stock number. Makes it easier to remember once you know. Anyway, 8103, let's fix that. 8 1 0 3, and there we go. So voltage output, we're just scrolling through, and right now it is set to output low is 0 for temperature. This is for the range. Output high is 1000, and the volts is 0 to 5 volts. So let's change that. It's got 0 to 5, 1 to 5, and 0 to 10. So let's just do the 1 to 5 first of all, and we'll say tick. And you can see my meter has immediately gone into overload because the voltage output has changed. So now it's saying 1.08 volts on its output, because it's reading the same. If you press both buttons together, you get out of that mode. So it would be 23, so say 23 degrees again. So it's now got a 4 volt range, not a 5 volt range, because we're 1 to 5 volts. So 4 divided by 1000, which is still our range, equals 4 millivolts per degree C, and we've got 23, so multiply by 23 equals 92 millivolts plus the 1 volt offset, which gives us 1092. So we've got 108 on the meter here at the moment. So it's probably within its specifications, because it's plus or minus 1.5 degrees, and we're very low in the degrees ranges here. So the next thing, let's go through again, and we'll change it to a 0 to 10 volt range instead. So voltage output change, we'll leave it as low 0 to 1,000. Sorry, we're changing, yeah, leaving that. So we're changing the voltage range this time to 1 to 10 volts, and we'll say OK. Now it basically will reflect the temperature. So we're reading 22.9 and we've got 22 millivolts. If I put my hand in front, I'll measure my hand, and we've got 34 and we've got 34 millivolts. So that's absolutely perfect. Now, if I wanted this to be much more sensitive, say between 0 and 100 degrees, then what I can also do with this is go in here, we'll go back to the same place, output voltage, and we'll change the low, we'll leave that at 0, but we'll change the high range from 1000, we'll change it down, I think I'm going the long way around here, I'm going to take it down to 100, right, which is the minimum. Now when I do this, we're going to get 10 times the range. So as you can see, the room temperature was about 22. So it's 23. We got 22.7, 22.8 on there, 22.9, which means now we've got a much higher voltage coming out of this for a smaller range of temperature, which could be very useful in certain situations. Put my hand in there, we've got 34, we're reading 3.4 volts, which is excellent. Now, if you say if you were using it for measuring something that was relatively an ambient kind of temperature, then this would be perfect. If you were measuring something else that may be 0 to 500 degrees centigrade, you could set your voltage output to represent 0 to 5 volts and the temperature range to be 0 to 500 degrees C. And it would then scale that output to be exactly that. So your 0 to 5 volt range in this case would be a direct correlation to the temperature, and literally you could just put a DMM on there or any voltage meter, and it would give you a direct reading without having to scale anything. You can change the emissivity just by going up and down. Well, I'm going to leave this at the default for now. I think you have to go back all the way. There is no quick way. Lock sensor. Reset alarm if you have an alarm. So your display, you can have display temperature raw or temperature units. Temperature screen, you can turn the screensaver on and off. Currently it's on. Rotation normal. So raw here, if you go in here, you could tell it the display to display average, the filtered, or the raw. Celsius or Fahrenheit. Screensaver always on or give it a timer. Rotation. And back to raw again. So let's get back out of there. So alarm for resetting it. Lock the sensor. So once you've done changing all the values and you don't want somebody to mess with it later on, first of all, there probably is a way of setting the pin number. Maybe you set it when you lock it now. Let's just try this. So enter pin. Okay, so it wants me to put in the pin number. So we'll put in the same one. So 8, 1, 0, 3. Hoping that's correct. And you press enter, 8103, and your sensor is now locked. So you can't make any other adjustments. And there you go. So aside from actually using this in some experiments now, which I will be doing, that pretty much completes the review. This is a very nice little unit. As I said, RS Components sent this to me for free to have a look at. They've just released it on their website under the RS Pro brand. From what I've seen here, very, very easy to set up, very easy to adjust, very easy to read, and very easy to integrate into other devices. Yeah, coming up soon is I'm going to be doing some updates to the Semantic 2020 and 2040 IoT gateways that I have to put the latest version 2 firmware into them. And what I'll do is I'll hook up one of these and show you how to program it using Node-RED to read the temperatures and put it onto a website. I've also got to do some updates to my heat beds on my 3D printers, and what I'll do is I'll use this to actually make sure that my temperature readings are close as they need to be for the sensing. So it will be handy for a lot of different things around the workshop, as well as use with some experiments. So anyway, that's this one for now. To buy this unit, you can get it from RS Components. I will provide a link in the description so that you can go get one of your own if you wish. You can get them from RS Components in Europe. So I'll provide the links to them, as I said, in the description. And I will see you on the next video, and I will let you know as soon as I have some more experiments being done with this temperature sensor.